Good afternoon. Before starting my presentation, I would like to express my gratitude for inviting me in this great event. This is the Global Innovation Festival. I was the research professor in KAIST, but now, actually last month, I moved to industrial field by working for Goyoung company. Actually, today my presentation is the first public action after changing my position. Today I would like to talk about medical robot and smart manufacturing based on research activities, especially done by Goyoung. I was a robotic engineer in LG during my younger ages, and after leaving industry, started the teaching job in Someone University for 18 years more, and stayed in recently in KAIST for 5 years. Rest 20 years was my energetic times for contributing to Korean robotic industrialization as planner, policy establisher with the government side, particularly in medical robot. Right. This is my topics on today. First, the company introduction, and secondly, I will speak on the trend on medical robot internationally and domestically, and I show my smart manufacturing research activities happening in Goyoung company. Let's start with the company introduction first. It is established in 2002, and 19 years later, the Goyoung is grown to medium level size of company with 684 employees and a revenue of 179 billion won last year. We are producing the inspection robot which determines autonomously the failure in manufacturing electronics PCBs. For example, smartphone, automotives, and computer servers, and medical devices. Each factory requires 100 accuracy for detecting anomaly in smart manufacturing lines of a plant, which are now operated by robotics and based on artificial intelligence. We started the research neurosurgery robots by launching a national project just 10 years ago, and finishing the project was successfully, and the recently acquired the approval from KFDA after clinical test for 2 years. The commercialized version of medical robot, now named as Chimero, was first installed in Severance Hospital last year, and this year we secondary version installed in Samsung Seoul hospitals. Next, I will briefly introduce my survey on the state of global companies producing or developing medical robots. Let's briefly look into medical robot market situation. According to the market researchers, the global medical robots size is rapidly growing with the average of 20% in CAGR. In particular, surgical robot market is rapidly growing now. Let me start with the definition of and classifications of medical robot. By the definition of KFDA, the medical robot can be a surgery robot, rehabilitation robot, and surgery simulation. Today, I will talk about the trend and its future on particularly surgical robot. It can be its applications area wider. Hospital service robot, nursing robot, and bionic arm can be included to medical robot. Surgical robot needs two core technologies, which are intelligent eyes and intelligent hand. In those technologies, controlling surgical instrument precisely and navigation based on computer and sensors. Let's look around the global surgical robot. First, intuitive surgical, which is positioned in a world top ranking in surgery robot and surgery robot industries. Worldwide, 5,500 robots more are working in hospitals globally. 3 years ago, recently, they introduced a new model of surgical robot like this, the single port platform, which needs only one inlet in human bodies. As a result, the patient can be recovered rather than 2 weeks very quickly. So its innovations shows the medical robot future. Let's look into its surgery robot action. Johnson & Johnson is now becoming the strong competitor as a fast follower. This company acquired the Bob surgical robot, which was the son company of Google in 2019, and also acquired the OssoHealth company with FDA approval by $3.4 billion. It expanded the domain to knee replacement by acquiring the Orthotaxis. The Hugo system of Medtronics, which is the world top medical company, is remarkable. It acquired major Robotics for $1.70 in December 2017, agreed with the Titan Medical to process the development of surgical robot in this year. Surgical robot, which is the upgradable, modular, and able to support laparoscopic application. EU and US regularly approved the Hugo system this week. They seemed to challenge to market leader intuitive surgical, Da Vinci, a single port platform I shown before. Stryker is, we should pay attention to Stryker, which is also a major player in surgical devices. They acquired the Mako Surgical by $1.8 billion and became the top players in the field of orthopedic surgical robot, replacing knee with artificial joint. More than 1,000 orthopedic surgical robot was now working in global hospitals. With the intuitive surgical, the Stryker also plays key roles successfully in surgical robot industries. Finally, I would like to introduce the German company, the Siemens Healthineers. In 2019, the company acquired the K.C.Koh Indus for $1.1 billion. Its main field is the telerobotic vascular robotic surgery, which uniquely approved the FDA. The robot named GRX is the innovative robot which can use the general catheters, guidance wires, and the stent. By teleoperation, the surgeons can avoid the excessive exposures of X-ray radiations. Now, let's briefly look into Korean history of medical robot. First, 2002, orthopedic surgery of knee replacement was performed by Dr. Lee Chun-taek. 2005, the first laparoscopic robot surgery was performed by Dr. Lee Woo-jung in Severance Hospital. 2009, Korean Society of Medical Robot was established by Dr. Kim Young-soo. 2010, Mire Company launched the laparoscopic robot project supported by MOTI, Korean government. 2011, Go-young launches the neurosurgery robot project, which also supported by MOTI, Korean government. 2012, Curex launches the national project of orthopedic robot supported by MOTI. Three major project was the start of medical robot in Korea. 2016 clinical test project supported by MOTI was first planned, and after two projects, the Mire and Go-young can acquired the approval from KFDA by the product level I and cameras. After a clinical test, both company can installed in hospital. In particular, Go-young's neurosurgery robot Chimera installed last year in Severance Hospital, and this year installed the second version of a medical robot in Samsung hospitals. Now, I would like to introduce the Go-young robot from now on. Deep brain stimulations robotic surgery is now commercialized. The robot platform and navigations with development and KFDA approval. X-ray based on a spine surgical robot system is also now developing with the digital X-ray source, and the navigation systems for 2D and 3D registrations, and also the instrument for spine surgery is now developing. In DBS robot system, the new concept of a robot marker, which has more accuracy, performance rather than NDI sensors, which are now mostly used for Medtronic navigation systems. We have more performance, roughly 2 or 3 times in the view of accuracy. The user convenience is now being improved by a clinical test using cadaver and phantom experiments. For the application in hospital, we need more equipment or accessories for this surgical operations. We developed the universal marker and clamp system for surgical instrument tracking, and also developed the aiming tool for surgical instrument guidance, various accessories for navigation hardware for fixture of a patient in the surgical rooms. Now, I will introduce the navigation software based on AI application. The navigation and the surgery planning is the key role and key action part of neurosurgical system. For the autonomous path planning, software will help the surgeon for accurate and successful operations. The machine learning based image segmentation is used for planning software, and optimal path. Optimal path is also recommended for surgeon before operations. The optimal solutions resulted from the well-known reinforcement learning, which was famous due to AlphaGo. I will show you some intermediate autopath planning result, which is undergoing in our US Research Center. For finding the optimal path, some hyperparameters such as hard threshold or the soft threshold are investigated in the training stage. This shows the recommended result. For the autonomous path planning, whole brain image should be automatically segmented by a structure of its brain internal organs. With machine learning on deep networks, we can extract the features and get the brain segmentation like this. The skull segment is also obtained from the artificial network, which will be used for finding entry point of DBS electrode load. In order to get the approval from FDA, the document making is very important. We performed it concurrently, keeping standard based on IEC 62304 requirement and its updates. The process for the technical reports are simultaneously ongoing for FDA approval, which is planned next year. After clinical test for 2 years, we finally installed our commercial version of neurosurgery robot in Severance Hospital in 2020, last year. Up to now, 7 cases for robot surgery and 7 cases of navigation based surgery are successfully performed. It's really a meaningful and honorable instance for a long time our effort for developing our domestic surgical robots, which are supported by our government. This year, the next version of our commercial neurosurgical robot was installed in Samsung Hospital. The version of 2.3 KPDA approved this year, secondly, and 2 demo cases were successfully performed. One is the biopsy operation, and the other is the DBS operations, which is the first DBS operations case in Korea. And after this, I will show some video clip introducing our commercialized stereostatic brain surgery robot. 네. K.C.Koh consists of a guidance robot and navigation platform, providing a solution broad range of stereostatic imaging. It has consist of a tracking sensor, software, markers, and guidance system. Robotic guidance system is attachable operation table side rails, enhancing the efficiency and accuracy of a robot system. Proprietary optical tracking sensor and markers ensures precise targeting by tracking patients and surgical tools. Using smart PPR, a surgeon can register patient visual points to match 3D sensor. Also with trace mode, frameless surface matching registration is available. Surgeon select a surgical plan on navigation software which create the 3D model. With the tool, guide drive, depth electrode biopsy needles can be inserted into exact selected area. Surgeon is able to fine-tuning target entry points during surgery. It has provided reliability, accuracy, and multiple applications. Now, I would like to move on my topic to the perspective to the future of medical robots. Like autonomous navigation of an unmanned vehicle, the surgery robot surgery process in the operation room will be automated in the long run. Because the robot surgery will be safer and more successful rather than human surgeon's operation. Because by proceed on computer, robot, AI technologies, the innovative technology will be realized in near futures. This trend will not be selectable but essential. Of course, at that time, the medical doctor also necessary. They will make an important decision during the robotics operation as the supervisory directors of operation room. Future medicine environment will be completely digital transformed, and the hospital management system will be integrated with AI, robot, big data, and cloud-based systems. Robot devices will be combined with the integrated system, and therefore, individual technologies and multiple robotic products are accumulated in the total control system. And finally, AI will be total controller of the hospital system as well as the personal healthcare system. A keyword of IoT will change to AIoT and finally evolved to ROT, which means of robotization of things. In final chapter of my talk, I will show how AI can also change the conventional manufacturing process to the smart manufacturing process by introducing Go-young companies listen to workshop need. Smart SMT manufacturing process is gradually decisive to the competitiveness of the SMT robot I showed in chapter 1 previously. By machine learning, which trained the network model by big data, accumulated big data obtained by inspection machines, the process can be modeled and optimized by the adjusting parameters Goyoung inspection machine, so SPI, pre-AOI, post-AOI, then can control printer, mounter, and deploy ovens. With the optimally adjusted parameters such as printing speed, replacement period for printers, and mounting offset position for mounters, and temperature profiling for reflow oven can be optimized by the process controller based on AI. Many customers use different models of equipment in SMT lines. We designed the optimization platform named as KPO, which plays a role of optimizing process based on the data of our inspection machine gathered during the manufacturing process. This slide shows the failure cases which can occur during the SMT manufacturing process. The factors for the failure can be analyzed by the KPO network, which is operated based on the artificial neural networks. Then the printer's control parameters such as squeezing pressure, printing speed, and replacement times are being adjusted by the output of the networks. This failure shows the cases occurring in the mounting processes. The network also analyzes the offset position, which is feedbacked into mounter process. KPO is born to help users with AI-aided tool to analyze and optimize the SMT process by optimizing key parameters generated by state-of-the-art machine learning data modeling technologies. I will show you our public relationship video for this smart solution. Concluding remarks. The robot AI trend. Robot industry can be the key factor of economic growth engine of a country. Fourth industrial revolution, which also called digital transformation, the core is robot and AI. The robot, AI, IoT, 5G will make the society more smarter. Finally, we can realize the control in to be utopia which humans are happy and healthy. Thank you.